Okay, for this one we are going to start talking about quadratics, and we are going to graph a quadratic, and I just want to remind you that it is the x being raised to the second power. That is what makes it a quadratic. So here I am going to rewrite this as f of x equals negative 1x squared plus 1x plus 6. And that's important for you to remember that the negative in front of this x right here is not being squared. Only the x is being squared. Okay? Next, I want us to look at our vertex. We have to find our vertex before we graph it. We use negative b over 2a. That is going to be given to you on your formula sheet for your final exam. So when you see negative b over 2a, know that that is what is helping you identify your vertex. So negative b over 2a, our b value is 1. So we have negative 1 over 2 times our a value, and our a value is negative 1. So we have negative 1 over 2 times negative 1. That leaves us with positive 1/2. So the x value of our vertex is going to be positive 1/2. The x value of our vertex is also our axis of symmetry. So the axis of symmetry is x equals 1/2. Now, in order for us to find our y value of our vertex, we take our 1/2 and we plug it in for x. So I am going to have negative 1 times 1/2 squared plus 1/2 plus 6. Okay? So 1/2 squared is 1/4, and then we multiply that by negative 1. So we have negative 1/4 plus 1/2 plus 6. Okay? Hopefully you are able to identify that negative 1/4 plus positive 1/2 is a positive 1/4. Now, let's change this 1/2 to a common denominator of 4. So 1/2 is 2/4. 1/2 is equal to 2/4. So negative 1/2 plus positive 2/4, that's where we get our 1/4 from. And 1/4 plus 6 is 6 and 1/4. You could change that to 25 over 4 if you wanted to. That's completely reasonable. But because we are graphing it, it's easier for us to keep it as an improper or as a mixed number, and that's what that is. So let's mark our vertex. We're going over 1/2, and then we are going up 6 and 1/4. So our vertex is going to be about right there. And it's not exact because we're graphing, but that's where it's going to be. Now, our y-intercept, the way that we get our y-intercept is we plug in 0 for x. So for our y-intercept, we're going to have negative 0 squared plus 0 plus 6. Okay? So we are left with 6. So our y-intercept is going to be positive 6. And I am going to go ahead and put a dot right there. It's very close to our vertex. Okay. Now, in order for us to find our x-intercepts, we are going to factor our polynomial. So we're going to go back up here, and I've got negative x squared plus x plus 6. Now, to find our x-intercepts, we set this equal to 0. And because we've got an a value that's a negative 1, sometimes that gets a little hairy. So what I'm going to do is I'm actually just going to divide everything by negative 1. I have divided the entire function by negative 1. So this becomes x squared minus 1 minus 1x minus 6 equals 0. Okay, so that's what's happening right there. Now, this is easier to factor because we have an a value that's positive 1. So what I'm looking for here is I am looking for two numbers where my sum is negative 1 and my product is negative 6. So my sum is negative 1 and my product is negative 6. So if I have the numbers positive 2 and negative 3, when I add those two numbers together, I get negative 1. When I multiply those two together, I get negative 6. And that's what I'm looking for. So when I factor x squared minus 1x minus 6, I will get x plus 2 times x minus 3. And that is set equal to 0. So if these are my factors, my intercepts are negative 2 and positive 3. Okay, and we can write that as negative 2 and positive 3, or if you want to write those with as an ordered pair, then that is fine. I'll erase some of this for us right now so we can kind of make it all clear. If you want to write that as an ordered pair, then you can have negative 2, 0, and 3, 0. Okay, so I have positive 3 right here, and I have negative 2 right here. Okay, and that is actually enough for us to go ahead and sketch the graph. I'm going to go ahead and identify the axis of symmetry 2. You are not required to do that, but I do want you to be aware of my axis of symmetry. Okay, there you go. There's my axis of symmetry. Now, our last question is talking about our range. I want to remind you, range deals with our y-axis and our y values. So in a quadratic, you are either going to have a maximum or a minimum. Now, this one is giving us a maximum because we have a top value. Our range always is going to deal with the y value of our vertex. So we're going to be dealing with 6 1/4. And it's always going to include that value. So it's going to have something to do with the brackets with 6 1/4. Now what we have to decide, are we going from negative infinity to 6 1/4? Or are we going from 6 1/4 to infinity? So in this situation right here, the highest value that we go to, because we have a maximum, is 6 1/4. So our range for this problem is going to be negative infinity up to and including 6 1/4. So there we have our graph of the quadratic, negative x squared plus x plus 6. Something that you can also do is you can always use your graphing calculator to confirm that you have everything correct here. And I would encourage you to do that. Okay?